the metric system at all to begin with. Okay, so we're gonna describe what's called the base unit for the metric system, and I want you to kind of I maybe need to reframe what I put here and what the metric system calls its base units. Okay, when we say base units here, sorry, you need to have notes out. If we don't have notes out, let's get those out. When we say base unit here, we mean like the most commonly measured unit. Okay. The most commonly, I can't spell today. Commonly used unit, okay? When we say base unit here for the metric system, these are the most commonly used units for each type of measurement. When we say base unit on our prefix chart, when there's base unit right here in the middle, that just means like the unit by itself with no prefixes. So meter, gram, whatever. Sometimes you'll hear me call this the simple unit. So meters, seconds, grams, liters. I might call those the simple unit with no prefix, okay? You'll know why I'm making that distinction here in just a second. But the base units for the metric system, there's 7 different types of base units, okay, or base measurements. Basically 7 different types of measurements you can take and then the units that go with them. So the first of which is the unit for length. The base unit or the most commonly used unit to measure length in the metric system is the meter. I think most of you probably would have guessed that, right? Meter. How long is a meter? Like hold up your hand. Show me how long a meter is. Right? Roughly 3 feet, 3.28 feet. Okay, that's roughly how long a meter is. Okay, we have meter sticks that we use a lot, but sometimes we get almost like, I don't know, we kind of forget that when we talk about measurements, they mean real life distances and real life masses. And so we kind of forget how long a meter is. And if we think through unit conversions with just like a common sense brain, right? If I'm converting 0.2 meters to miles, I want you to just think about that question, right? Real quick, is before we even get into unit conversions, if I say I want to know how many miles are in 0.2 meters, would you be expecting your answer to be really big or really small? Really small, right? But sometimes we get into these problems and we get answers that are completely irrational and we don't stop to realize that, right? But if I'm converting 0.2 meters to miles, I should get a tiny, tiny fraction of a number, right? Because there is a tiny, tiny fraction of a number of a mile that's in this long, this distance or whatever it might be. So I want you to think about as we go through this, we really are checking for rational numbers as we go. Okay. Next base unit is for mass. And the base unit for mass is actually kilogram. And so that's the reason I made the distinction between a base unit and what I call a simple unit. Okay? Do you have any idea why the base unit for mass might be kilogram instead of gram? Any idea? Yeah.
Because it's like more commonly used.
Yep. But why would it be more commonly used? Yeah.
Because grams are too small.
Bingo, right? Grams is a teeny tiny unit. And so if we measured everything in just grams, we would ended up with thousands of grams in our measurements. And so rather than measure and say it had a mass of 27,248 grams, right? That just seems cumbersome. So you'd say it has a mass of 27 kilograms. That's the only reason, right? Grams just represents a really, really small mass. And so working with kilograms, it's much more applicable and it kind of gives us a more a more reasonable number, right? Rather than working in the thousands. So there's the difference that I wanted to say. When I ask about the base units, that's these. But the simple unit for mass, right? The simple unit that fits right in here is just gram. That's where it kind of goes in. Right? Do you see the difference? All right, the next one is for time. That's measured in seconds, right? The unit that we use for temperature is something called Kelvin. Have you heard that before?
Yeah.
Kelvin, okay. What's another one that we might use? Celsius, right? We might use Celsius instead of, what do we measure temperature here in the U.S.? Fahrenheit, right? And so why is it not good for us to use Fahrenheit in our scientific measurements?
Number's too big.
No, okay. That's a good thought, but it doesn't have anything to do with the size of the number. Why is it important for us to know the metric system at all?
It's used a lot in science.
Right, and so why is it used a lot in science? Why do we choose to use the metric system? Or why do we in the United States need to learn the metric system? Yeah. The entire world uses it. So if we in the US are submitting our measurements and submitting our reports in pounds and ounces and quarts or inches or whatever it might be, everyone else in the rest of the world is like, I don't know what that is, right? And why are you using that, right? So we use it to keep our scientific discoveries and reports and all that stuff universal, okay? So that's the reason. We use Fahrenheit, so we need to convert that to Celsius, then to Kelvin. Okay, the last couple are different, are ones we don't, these we'll use a lot. Amount of substances is a mole. Have you heard that before? Anyone heard that term, mole, before? I'm not talking about the animal, right? We're talking about how much substance, that's called a mole. And then the last two are ones we don't use a whole lot. Luminous intensity, what's another word to describe that?
Light.
Yeah, how much light there is in something. They're measured in candelas. And then electrical current is measured in what's called an ampere or an amp, right? Have we heard that before? Right, where do we normally hear that in?
Music.
Yeah, music, right? Speaker systems, how much of that's flowing through there. What's another way that we sometimes measure luminous intensity? Lumens is one, Watts is another, right? Both of those kind of give us different. Lumens is really the unit that does measure intensity. Watts has more to do with the electrical current that's running through it as well. So it's a little bit different. There. Watts is actually the unit for what's called power, all right? And so we'll look at that in a different class. But for our class, we're going to use conversions basically here to here, okay? Let's talk a little bit more about what a mole is. Okay, before I go to that, tell me how many is in a dozen of anything? 12, right? Did I have to tell you that it was a dozen roses or a dozen donuts? Does it matter what it is? A dozen is still a dozen, right? And a dozen is 12. Well, a mole works the same way, okay? A mole is this many of anything, okay? And we'll talk about this as we get into chapter 3, really. But 1 mole is equal to 6.022 times 10 to the 23rd of anything. Of anything, okay? Have you seen that number before? It's called Avogadro's number. And so this number, right? Imagine we move the 0 23 places this way. Right? Or move the decimal, 23 places that way. It's a huge, huge, huge number. And so a mole represents this many of anything. Usually we apply that to the number of atoms. Right? A mole of atoms would be 6.022 times 10 to the 23rd of that particular atom. And so we're going to get into that as we go really into chapter 3. But we need to understand that moles measures the amount, like the counted quantities of a substance. If I wanted to measure mass rather than moles, what's the difference there? Got any idea? What's the difference between measuring something, its mass, or the amount of the substance?
It's more units, maybe?
Kind of. It does have different units. So let's talk about this. Mass is how much something weighs. Mole, or the amount of substance, is how many of the thing there are. So I could have 2 atoms of hydrogen and 2 atoms of oxygen. I've got the same amount of both of those things, but do they weigh the same? No. 2 atoms of hydrogen weigh 2 grams, right? 2 AMUs. But 2 atoms of oxygen would weigh 32 because each oxygen atom weighs 16. Do you see the difference there? Right? So the amount of substance and the mass of the substance mean totally different things. Okay? They represent totally different quantities. So I need you to make sure we understand that. Okay. Here is, again, kind of the unit chart that I laid out for you. So this will be something that will be available to us every time that we need it. But I want you to kind of take one more notice on the sheet. Do you see how from the top to the bottom, we change where the 1 is?
Yeah.
Right? Here at the top, I always give the larger unit the 1. And then I tell how many of the smaller unit are contained in that larger unit. So a kilogram is equal to 1,000 grams. A grams is a smaller unit than kilograms. And so I like to give the larger unit the 1, and then we say how many little units are found within that big unit. So you'll notice here is the simple unit or grams, whatever it would be, and then below that represents units smaller than that simple unit. So 1 gram would be equal to 10 decigrams. okay? Or 1 gram would be equal to 1,000 milligrams. Okay, so the 1 changes there, but I always like to give the larger unit the 1. Okay? A couple other units that I just want you to be familiar with that we'll use to kind of do conversions. A milliliter. Tell me, what is milliliter used to measure?
Like fluid ounces.
Good. Or what's another word for that?
Yeah.
What is, yep. Milliliters are used to measure volume. They're used to measure volume. Okay? And so a milliliter is equal to 1 centimeter cubed. I need you to write down that conversion. Right? If I have a cube with 1 on each side, that's 1 cubic centimeter. 1 centimeter on each side, right? Because the equation for volume of a cube is length times width times height. Would we agree with that? Do we know how to find the volume of a cube? Length times width times height. Okay, so 1 centimeter cube is equal to a milliliter of any liquid. Do you know what else this is called? A cubic centimeter? Sometimes people call these cc's. Where do you hear that term? I need 50 cc's of something. In medicine, right? In medicine, also measure temperature in degrees Celsius. And I'm going to give you a couple conversions here to go from Celsius to Kelvin. Okay? If I have a temperature in Celsius, I'm going to add 273 to that number. And that would be equal to my measurement in Kelvin. Okay? So I'm going to add 273 to that number, and that's my temperature in Kelvin. Okay? So if I had a temperature that was 0 degrees Celsius, how many Kelvin would that be? 273 Kelvin.
Does the Kelvin sign have the little...
Nope. Kelvin, we don't call Kelvin degrees Kelvin. I don't know why. Okay, we don't. It's just capital K. Okay? So what temperature, tell me what temperature does water freeze at? In Fahrenheit first. What's the freezing point for water in Fahrenheit? 32. Good. And what's that in Celsius? 0 degrees Celsius, which means water would freeze at 273 Kelvin. Right? That's the temperature value that water would freeze at. If water boils at 100 degrees Celsius, what would that be in Kelvin? 373 Kelvin, right? I add 273 to 100.
Wait.
If I'm at
0 Celsius right now, and 0 Celsius equals 273 K.
Right?
So 100 C would be 273 times 100.
No, plus 100.
Plus 100.
Plus 100.
It's whatever's in Celsius plus.
Plus 273. Okay? So how would I need to convert back? If I wanted to go from Kelvin to Celsius, how would I get back?
Subtract.
I just subtract. Okay, so I would take my Kelvin temperature minus 273, and that would be my temperature in Celsius. Very good. Okay, so if I need to go back, I would go there. Does anyone know what it's called if we were to reach 0 Kelvin?
Absolute 0.
It's called absolute 0. Very good. And what happens at absolute 0?
I can't get any colder.
That's true. But what happens at absolute 0? It is pretty cold. I would agree with that. Okay, at absolute 0, written down. But these are measurements that allow us to switch from one to the other. US and metric. Again here, I tried to give the larger unit the 1. Okay, so it's not always the US system that gets the 1 or metric, but I try to give the larger unit the 1. Why is it that we use units? Okay, what is the point of a unit? First of all, do I need to explain what a unit is, or do we feel pretty good with that? The unit is the label that goes after the number. Okay, so if I say it's 29.4 meters, there's my unit. Okay, it tells us what was being measured. Because if I just submit something that's 29.4, that number has absolutely no meaning. Right? Without a unit, our numbers have absolutely no meaning. They don't tell us anything. It could be 29 grams. It could be 29. Without a unit, we don't know what that number is for. So the unit is the label that goes after the number. And it tells us what was measured. Okay? So your goal, when we do homework and we do measurements and we do labs, all that kind of stuff, your goal is to never have a plain number, right? We want to make sure that we have a unit. If a unit is given, right? Sometimes we have to do math that doesn't have units, that's fine. But if we are given a unit, we need to make sure we carry that number throughout, that unit throughout, okay? So we're going to jump in with some conversions, and we're going to start with the U.S. conversions because those are ones we're most familiar with. We're most familiar with the U.S. system conversions, so we're going to do those first. And I'm going to kind of teach you the method that I use for unit conversions. Have you guys done unit conversions in any math classes? You do any of that kind of stuff in math, or a little bit, maybe so? Okay. All right, let's try this. If I was going to convert inches to miles, I want you to tell me, can you think of a path that can get us from inches to miles? Can I go directly? Do I know how many inches are in 1 mile? No, but I can go to feet. I can go feet to miles, okay? So I'm going to go inches to feet, feet to miles. I would agree with that, okay? So here's my system for unit conversions, and it works every time, all the time, okay? I'm going to set up my system using what's called a T-chart. Okay, using a T-chart, and we use this for any type of conversion. We always start our T-chart with what we know. So I'm going to write down 36 inches, and then I'm going to draw kind of a sideways T there. Okay? This system is essentially multiplying a bunch of fractions together, but we put them into one little chart so that we only have to do math one time. Okay? We only have to plug into our calculator one time. All right. So if these are essentially fractions that are being multiplied together, this is essentially over 1. Now, I don't ever draw the 1, so I don't even need you to do it, but I just want you to see that there is something there. I just don't ever draw it. Okay, I never put the 1 there, but essentially it is. But if inches is in the numerator, and I need to move from inches to feet, I need inches to cancel. Okay, I want to convert from inches to feet. And if inches in the numerator, where do I need to put it to get it to cancel? In the denominator. So I'm going to put inches, and we said we're going to go from inches to feet. So that's the next section of my chart, okay? Now, I have to make this part of my chart true. Okay, I need to make this vertical column of my chart be true. So what's my bigger unit here? Are inches or feet the bigger unit? Okay, so feet gets a 1, and I'm going to tell how many inches are in 1 foot. 12. Okay, and look, my inches unit gets canceled. And if I took 36 divided by 12, I would get 3 feet. Don't you agree? Okay, but I don't want my answer to be in feet. I want my answer to be in miles. Right, I want my answer to be in miles, so I'm going to keep going. I'm not going to do any math yet. I'm going to keep going. If feet is in the numerator, where do I need it to go? Denominator. And I said I want to go to miles. Miles is abbreviated MI. Why is it not just abbreviated M? That would be meters. Very good. Okay, so now which of those is the larger unit? 1. How many feet are in a mile? No, how many feet are in a mile? 5,280 feet are in a mile. Okay, now does my units, feet, cancel?
No.
Yeah, one's in the numerator, one's in the denominator, so they cancel. And I'm left with the unit that I want, which is miles. Now I'm able to plug it in because I've got inches canceled, feet canceled, and I'm left with miles. So now to do the math, the rule for the math is if these are all fractions that are multiplied together, I'm going to multiply across the whole top. But I've got 36 times 1 times 1. Do I really need to plug that into my calculator? No, you don't. Okay? Then I divide by the whole bottom. You're going to hear me say this a lot. Multiply across the whole top, divide by the whole bottom. So that means I'm going to take in my calculator 36. Get your calculator out. 36 divided by 12. And then I'm going to go again, divided by 5,280 feet. And I got in my calculator 5.68 times 10 to the negative 4th miles. Your calculator might have also given you a number that looks like this. And I rounded 568. Okay, mine actually was 5.68181818. Okay, I rounded that. Did your calculator give you something that looks like that? Yes or no?
Yeah.
Okay. Here's the rule. If these are both in the denominator, in my calculator, I just divide by everything that's on the bottom. If you feel like you need to multiply them together, they have to go in parentheses. So you could go divided by parenthesis 12 times 5,280, close your parenthesis and do it that way if you wanted to. I don't prefer that. Okay, so you can do it however you want. But my number came out really small number of miles. Does that answer seem rational? Yeah, were we expecting to have a really small answer here? Right? 36 inches is this long. So that's a really small fraction of a mile. So that should mean that our answer is rational to us. It makes sense. How many of you are familiar with scientific notation like that? Okay, we're going to do a lot of work with scientific notation to make sure that we're familiar with numbers written like that. But these two numbers are identical. These two numbers represent the same value. One of them is just written in scientific notation and one is not. Okay, so tell me what question. If I go 38 ounces to pounds, do you know how many ounces are in a pound? 16. And so since we know directly how many ounces are in 1 pound, we can do this in one step. Ounces to pounds. And I can put that number in directly. I don't have to do 2 different steps. I can say 1 pound is equal to 16 ounces. And I get 38 divided by 16 is 2.375 pounds. Okay, if I know the direct conversion, I can just do it in one step. But if I don't, I need to kind of walk out a path to get there like we did with inches and miles. Okay? I'm going to recommend that you kind of write out your path like we did right here, especially as we first get started on this.